The Order of Time, by Carlo Rovelli. Introduction. Have you ever met two friends, identical in every way, who aged at different speeds? Imagine one friend lives by the sea, down at the beach, while the other lives high up in the mountains. For years, they live their lives. They work, they love, they sleep, they dream. Then, one day, they meet again. And something is strange. The friend from the mountains looks just a little bit older. His watch has ticked just a few more seconds. He has, in a very real sense, lived more time. This isn't a fairy tale. This is the world we live in. Time itself passes faster in the mountains than it does at sea level. The difference is tiny, almost imperceptible, but it is real. And it is the first clue in a detective story that will unravel everything you think you know about time. Today, we journey into one of the greatest scientific mysteries of all, the nature of time itself. Our guide is the brilliant Italian physicist, Carlo Rovelli. His book, The Order of Time, isn't just a work of science, it's a work of poetry. Rovelli is a man who dedicated his life to quantum gravity, to understanding the very fabric of reality at its smallest scale. But he writes with the soul of a philosopher, and in this book, he takes our most familiar concept, time, and holds it in his hands like a delicate snowflake. As he examines it, layer by layer, it begins to melt, until nothing is left. This book has captivated millions around the world because it does something remarkable. It takes the most complex ideas from modern physics and makes them feel intuitive, personal, and deeply human. It asks questions that resonate with the core of our being. Why do we remember the past and not the future? What does it mean when we say that time passes? And what are we listening to, in the dead of night, when we listen to the passing of time? I want to make you a promise. If you stay with me on this journey, by the end of our time together, you will never look at a clock the same way again. You will understand that the steady, universal ticking we imagine is an illusion. You will see the world not as a collection of things, but as a symphony of events. And you will discover that the source of time, the great secret we've been searching for out in the cosmos, might just be hidden inside ourselves. This is the story of the crumbling of time, and the beautiful, strange world that is revealed in its absence. Let's begin. Book summary. We all feel it, don't we? Time. It's the most intimate and familiar part of our lives. We inhabit it like fish in water. It is the rush of seconds, hours, and years that carries us from birth toward nothingness. It's the solemn music that nurtures us, troubles us, and lulls us to sleep. The universe, we feel, unfolds according to the order of time. In Hindu mythology, this great cosmic river is pictured as the dancing god, Shiva. His dance is the flowing of time itself, the rhythm that upholds the universe. What could be more obvious, more fundamental, than this constant, universal flow? And yet, reality is rarely what it seems. We once thought the earth was flat, but it is a sphere. We once thought the sun revolved around us, but it is we who are spinning. And as Carlo Rovelli discovered as a young physics student, the structure of time is also not what it seems to be. In fact, our common-sense picture of time has turned out to be almost entirely false. The story of modern physics is the story of this illusion slowly disintegrating. It's like watching that beautiful snowflake melt, piece by piece, until it vanishes. The first piece to melt was the idea of unity. We assume that a minute for you is the same as a minute for me, and the same as a minute for someone on the other side of the world. One universal clock, ticking away for everyone. But it's not true. As we saw with our two friends, time passes at different rates depending on where you are. Time moves more slowly closer to a massive object, like the Earth. This isn't a trick of our clocks, it's a fundamental property of the universe. Down on the plains, every process is slower. The friend who stayed at sea level has lived less, aged less, his plants have grown less, his thoughts have had less time to unfold. Down below, there is simply less time. The genius who understood this, a century before we had clocks precise enough to measure it, was Albert Einstein. He asked a simple question: how can the sun attract the Earth from millions of miles away without touching it? He imagined that a large mass, like the sun, doesn't pull on the Earth directly. Instead, it warps the very fabric of space and time around it. A mass slows down the time in its vicinity. This is why things fall. An object doesn't fall because of a mysterious force of gravity. It falls because, here on Earth, it is simply following the natural slope of time, moving toward where time passes more slowly. Your feet, being closer to the Earth, are in a region of slightly slower time than your head is. The reason you are stuck to the ground right now is because of this subtle difference in the flow of time across your own body. Once you accept this, the idea of a single, universal time shatters. There isn't one time. There are legions of them. A different time for every point in space. Rovelli describes it beautifully. The world is not like a platoon marching in lockstep to a single commander. It's a network of events, each dancing to its own rhythm. If the world is upheld by the dancing Shiva, there must be 10,000 such Shivas, all dancing to different beats. The snowflake of time has lost its perfect symmetry. But surely, it still has a direction. This brings us to the second piece to melt: the loss of direction. The difference between the past and the future feels like the most fundamental thing about time. The past is fixed. We have memories, regrets, photographs. The future is open. It is uncertainty, hope, anxiety. A glass falls and shatters into 1,000 pieces. The pieces never spontaneously reform into a glass. Cause always comes before effect. This is the arrow of time. So, where in the fundamental laws of the universe is this arrow hidden? 19th century physicists went looking for it, and they found something deeply strange. In the elementary equations that describe the world, from Newton's laws of mechanics to Einstein's relativity to quantum mechanics, there is no difference between the past and the future. If a sequence of events is possible, the same sequence running backward in time is also possible. A movie of the moon orbiting the Earth makes just as much sense if you play it in reverse. There is only one exception. The arrow of time appears only where there is heat. This crucial link was discovered by a French engineer named Sadi Carnot, born of poetry and rebellion, who was fascinated by the new steam engines of the 1800s. He realized they worked because heat always flows from something hot to something cold, and never the other way around. This simple observation became a fundamental law of physics, formulated by a Prussian professor named Rudolf Clausius. A ball can fall and bounce back up. Heat cannot. Clausius gave a name to this one-way process. He called it entropy. Entropy is a measure of disorder, and the law says that in any isolated process, entropy, or disorder, can only increase. It never decreases. This is the famous second law of thermodynamics. It is the only equation in fundamental physics that knows the difference between past and future. Every time you see a difference between past and future, heat and entropy are involved. A ball rolling to a stop seems normal. A ball starting to roll on its own seems impossible. Why? Because the rolling ball stops due to friction, and friction produces heat. Even our thoughts, which always move from past to future, generate heat inside our heads. So the secret of time's arrow is hidden in entropy. But what is entropy? This is where our next hero enters the story. An engaging and tragic Austrian physicist named Ludwig Boltzmann. Boltzmann was the man who truly understood entropy. He realized that heat is just the microscopic agitation of molecules. A hot cup of tea is one where the molecules are moving frenetically. A cold cup is one where they are moving slowly. He then had a brilliant idea. The reason entropy always increases, the reason heat flows from hot to cold, is simply a matter of statistics. It's like shuffling a new deck of cards that starts perfectly ordered. Shuffling always creates more disorder, never more order. The natural tendency of everything is to become more disordered. The growth of entropy is just the natural increase of disorder. This was a genius insight, but it doesn't solve the mystery. It just pushes it one step back. The new question becomes, if the universe is always getting more disordered, why was it so incredibly ordered in the past? Why was the great deck of cards of the universe in such a special, low entropy state at the beginning? And here, Boltzmann delivers the most dizzying conclusion of all. He realized that the very notion of order and disorder depends on our perspective. It depends on the fact that we see the world in a blurred way. Think about that deck of cards. We say a deck with all the red cards together is ordered, but it's only ordered because we are paying attention to the colors. If we looked at every single scratch and crease on every card, every configuration of the deck would be unique and special. The idea that some configurations are special or ordered only arises when we ignore the microscopic details and lump things together. Boltzmann showed that entropy is precisely the number of different microscopic states that our blurred vision cannot distinguish. It exists because we don't, and can't, see everything. This leads to a shocking conclusion. If you could see the exact microscopic state of the world, all of its details, the difference between past and future would vanish. The arrow of time, the flow that feels so real, is a product of our ignorance. It is an effect of our blurred perspective on the world. Is it possible that something so fundamental to our experience, the passage of time, is just a kind of myopia? The evidence is overwhelming. All the phenomena that mark the flow of time are tied to the fact that the universe began in a state that, from our blurred perspective, appears incredibly special. Boltzmann's equation, which defines entropy in terms of this blurring, is carved on his tombstone in Vienna. A fitting tribute to the man who discovered that the river of time flows only because we see the world through a fuzzy lens. The snowflake has lost its unity and its direction. It's becoming a puddle. But the most devastating blow is yet to come. This is the end of the present. A decade before he figured out that mass slows down time, Einstein made another discovery. He realized that speed also slows down time. Let's go back to our two friends. This time, one stays still, and the other goes for a very, very fast walk. When they meet again, the friend who was moving has aged less. For everything that moves, time passes more slowly. This has been measured. A precision clock on an airplane runs slightly slower than one on the ground. This simple fact has an earth-shattering consequence. It means that the idea of now is meaningless. Imagine you have a sister who has traveled to a planet orbiting the star Proxima Centauri, about 4 light-years away. You might ask a simple question: what is my sister doing now? Rovelli explains that this is a question that makes no sense. It's like asking, what is here, in Beijing, while you're standing in Venice? The word here refers to your location, not a universal location. Similarly, now refers to your time, not a universal time. If you look at your sister through a powerful telescope, you are seeing her as she was 4 years ago, because that's how long it took the light to travel from her to you. That's her past, not her now. You could try to calculate what she's doing 4 years after the moment you see, but that doesn't work either. Because of the effects of speed on time, she might have already returned to Earth and be 10 years in your future. So when is now on that distant planet? The truth is, there is no now there that corresponds to your now here. Rovelli calls this the most astounding conclusion in all of contemporary physics. Our present does not extend throughout the universe. It is a bubble around us. For everyday life on Earth, this bubble is large enough that we can all pretend to share a single now. But as soon as we look out into the cosmos, the illusion falls apart. There is our past, the events that can affect us. There is our future, the events we can affect. But between the past and the future, there is a vast, extended present, an interval of time that is neither past nor future. For Mars, this interval is about 15 minutes. For the Andromeda Galaxy, it's millions of years. The idea of a single present, a now that exists for the entire universe, is an illusion. There is no great cosmic clock ticking off the moments of existence. The present of the universe is a meaningless concept. So what does the temporal structure of the world actually look like? Rovelli uses a brilliant analogy: a family tree. For any person, there is a cone of ancestors in the past and a cone of descendants in the future. But there are also many people who are neither ancestors nor descendants, cousins, spouses, friends. They are outside the cones. The structure of space-time is the same. For every event, there is a light cone of its past and a light cone of its future. Everything outside these cones is in that expanded present, neither past nor future. This is the strange, new geometry of the world that Einstein revealed to us. The snowflake of time has completely dissolved. We've lost its unity, its direction, and its present. What's left? This brings us to the final crumbling: the loss of independence. For centuries, we've been caught in a debate between two giants of thought, Aristotle and Isaac Newton. Aristotle believed that time is simply the measurement of change. If nothing in the world changed, time would not pass. Time is not its own thing. It's just a way of counting the ticking of the world's events, the rising of the sun, the swinging of a pendulum. Newton, on the other hand, imagined a true and absolute time. A time that flows on its own, independently of everything else, whether anything happens or not. Even if the entire universe were frozen, Newton's time would continue to flow, steady and imperturbable. This is the T in his equations, and it has become our common-sense way of thinking about time. So who was right? The answer, as it so often is, required a third giant to enter the dance: Einstein. Einstein's great synthesis showed that both were right, and both were wrong. Newton was right that there is something real that exists beyond the simple matter we see. This something is what we call space-time. But he was wrong to think it was absolute and independent. Aristotle was right that time is tied to the changing of things. But this thing it's tied to is not just ordinary matter, it's the gravitational field itself. Here is the key idea: space-time is not a fixed, empty stage on which the world performs. Space-time is the gravitational field. It is a physical, dynamic entity, like an electron or a ray of light. It is a vast, flexible jelly that can bend, stretch, and ripple. The slowing of time near a mass is just this jelly being stretched. The universe is not a story drawn on a fixed canvas, it is a superimposition of canvases, all interacting with each other. Time has lost its independence. It is no longer the king, ruling over the world. It is just one of the dynamic components in the great dance of the universe. But even this isn't the end of the story. Because the world is a quantum world. And when we apply the strange rules of quantum mechanics to space-time itself, the last vestiges of our familiar time disappear. This is the world of quanta of time. Rovelli is a world expert in this field, called loop quantum gravity. This theory tells us that, just like everything else in the quantum realm, space-time has three strange properties. First, granularity. The continuous, smooth flow of time is an illusion. At the smallest scale, time is not continuous, it is granular. It jumps from one value to another. There is a minimum possible interval of time, called the Planck time, an unimaginably tiny fraction of a second. Below that scale, the very notion of time ceases to exist. As Rovelli says, the good Lord has not drawn the world with continuous lines, with a light hand, he has sketched it in dots, like the painter Georges Seurat. Second, indeterminacy. In the quantum world, a particle like an electron doesn't have a precise position until it interacts with something. It exists as a cloud of probability. The same is true for spacetime. At the fundamental level, spacetime itself fluctuates. The very distinction between past and future becomes blurry and indeterminate. An event can be both before and after another event. Third, and most profoundly, Relationality. A quantum particle only materializes at a certain point in relation to what it interacts with. Its properties are not absolute, they are defined by its relationships. This applies to time as well. The duration between two events is not a property of the universe, but a result of a specific interaction. Time itself dissolves into a network of relations that no longer holds together as a coherent canvas. So, after this long demolition, what is left of time? Nothing. At the most fundamental level we know of, time does not exist. There is no special time variable, no past or future, no universal present, no continuous flow. We have arrived in the world without time. A strange, windswept landscape of pure change. But this doesn't mean the world is static or frozen. Far from it. The absence of time doesn't imply a lack of change, it implies that change is ubiquitous, but it's not ordered along a single line. The events of the world, Rovelli quips, don't form an orderly queue like the English, they crowd around chaotically, like Italians. The world is happening, everywhere, all at once. This is perhaps the most radical shift in perspective the book offers. We must stop thinking of the world as being made of things that persist through time. We must think of it as being made of events. A stone seems like a thing. But on closer inspection, it is just a long, slow event. It's a complex vibration of quantum fields, a process that holds its shape for a while before eventually disintegrating into dust. A kiss, on the other hand, is obviously an event. It has a limited duration. Rovelli's poetic insight is this: the world is made up of networks of kisses, not of stones. We are not things. A human being is a complex process. Food, information, light, and words flow in and out of us. We are a knot of knots in a vast network of chemical, social, and emotional exchanges. We are not beings, we are becomings. The physics that describes this world of events doesn't need a time variable. The fundamental equations of quantum gravity, like the Wheeler-DeWitt equation, have no t in them. Instead, they describe how all the variables of the world change in relation to each other. Time, as Aristotle first guessed, is just the measure of change. The theory simply describes the relationships between events. This is the barren, beautiful world without time. But if this is true, if time isn't real at the fundamental level, where does our time come from? Why do we feel it flowing, so relentlessly, from past to future? This is where the story turns into a detective novel. We are going in search of the culprit who created time. And, as Rovelli hints, like in the great tragedy of Oedipus Rex, the culprit may turn out to be the detective. The source of time is not out there in the cosmos. It's here, with us. It emerges from our particular relationship with the world. The first clue is blurring. Remember Boltzmann? Time zero exists because the past had low entropy. But entropy only exists because of our blurred vision of the world. So, our feeling of time is a direct consequence of our ignorance of the microscopic details. Time, in a profound sense, is ignorance. Rovelli, building on the work of the mathematician Alain Kuhn, shows how this thermal time emerges naturally from any blurred, statistical description of a system. When you can't see all the details, a special variable with the properties of time just appears. But this still doesn't answer the main question: why was the entropy of the past low for us? This brings us to the second and most crucial clue: perspective. Perhaps the universe, at its beginning, was not in a special ordered state at all. Perhaps it was completely random. The reason the past looks special to us is because we are a special kind of system that has a particular interaction with the rest of the world. Rovelli uses a powerful analogy. For thousands of years, we looked up and saw the entire cosmos majestically revolving around the Earth. It seemed to be the most fundamental property of the universe. But we eventually understood that the heavens weren't turning. We were. The grand rotation of the sky was a perspective effect, caused by our particular motion on this planet. The arrow of time might be the same kind of thing. The flow of time is not a property of the universe. It is a property of our perspective on it. Out of the countless trillions of systems in the universe, there are bound to be some that happen to interact with the rest of the world in such a way that, for them, the past appears ordered. We are one of those systems. And it's only in such systems, where entropy is increasing, that life, evolution, and thought are possible. We don't live where time flows. Time flows where we live. This is where the story of time becomes the story of ourselves. That low entropy in the past, that arrow of time, is what allows the past to leave traces. Fossils, craters on the moon, photographs, and, most importantly, memories in our brain. Without the one-way flow of entropy, everything would be perfectly reversible. Nothing could ever be recorded. The past leaves traces, the future does not. This is why the past feels determined and the future feels open. And what are we, as human beings, if not a collection of traces? Our identity is built on memory. I am not just this body, here and now. I am my mother's caresses, my adolescent travels, the books I've read, the loves I've felt, the mistakes I've made. I am a long, ongoing story, held together by the thread of memory. As St. Augustine observed centuries ago, the past exists as memory in the present, and the future exists as anticipation in the present. Time, for us, is a phenomenon of the mind. Our brains are time machines. They are not built to perceive the instantaneous now, which doesn't exist anyway. They are built to condense stretches of duration into a single perception, to hold the past in retention and the future in expectation. This is how we can hear a melody. A song only exists in time, but we hear it as a unified whole because our consciousness is a structure built of memory and anticipation. This, finally, is the source of time. The crumbling is complete, and the rebuilding is done. The uniform, absolute time we started with has vanished. In its place is a much richer, more complex picture. At the fundamental level, there is a world of quantum events, without a clear temporal order. Out of our blurred perspective on this world, a statistical, thermal time emerges. From our specific vantage point within the universe, this time appears to have a direction, an arrow, that allows for the formation of traces. These traces build up in our brains, creating memory. And this constant interplay of memory and anticipation within our minds creates the profound, personal, and emotional experience that we call the flowing of time. The mystery of time, in the end, is not about the cosmos. It's about us. We were looking for the ticking of a great clock out in the universe, but we were carrying the clock inside us all along. The emotion of time is not a fog that obscures its true nature. The emotion of time is its nature, for us. And this time, our time, is precious precisely because it is finite. It is the brief circle of our existence, a miracle of combinations that allows us to be here, to love, to learn, and to wonder. Commentary. Reading The Order of Time is like sitting with a wise old friend under a starry sky, having the universe explained to you in a way that feels both profound and deeply comforting. What Carlo Rovelli does so masterfully is to take a subject that could be cold and abstract, the physics of time, and reveal its deeply human core. The most powerful lesson, for me, is the idea of perspective. We so often search for absolute truths, for a single, objective God's-eye view of reality. Rovelli gently shows us that such a view may not exist, and that it's not something we should even want. Our experience of the world is defined by our being in it, not outside of it. The fact that the sky revolves around us isn't a lie, it's a truth about our relationship with the cosmos. And the fact that time flows for us isn't an illusion to be dismissed, it's the very source of our identity, our memory, and our capacity for love. This book reminds us that we are not separate observers of the universe, we are participants. our ignorance, our blurred vision, isn't a flaw. It's the very condition that makes our world, and our experience of time, possible. There's a deep humility in this idea. It suggests that the most profound truths are not found by trying to escape our humanity, but by understanding it as part of the fabric of nature. So, how can we apply these grand, cosmic ideas to our own lives, right here, right now? First, we can learn to embrace the present, not as a fleeting instant, but as our unique bubble of reality. Rovelli shows us there is no universal now. The only now that matters is the one we are in. So often, we live in the past, trapped by memories and regrets, or we live in the future, paralyzed by anxiety and expectation. This book is a powerful invitation to fully inhabit our own localized present, to recognize it as the only place where life truly happens. Second, we can see ourselves not as fixed things, but as evolving events. You are not the same person you were a year ago, or even a minute ago. You are a process, a story that is constantly being written. This frees us from the burden of a static identity. It gives us permission to change, to grow, and to let go of the parts of our story that no longer serve us. You are not a stone. You are a river. Finally, we can find a new relationship with the passage of time itself. The book ends on a surprisingly tender and poignant note, reflecting on death not as a terrifying void, but as a natural part of the flow. If our lives are a brief circle, then every moment within that circle becomes infinitely precious. The suffering we feel from loss is the flip side of the love we are capable of. The sting of time's passing is what gives each moment its sweetness. That was A Journey Through the Order of Time by Carlo Rovelli. We've touched on the major themes and the grand conclusions today, but I'll be honest with you, a summary can only ever be a map. The real magic happens when you walk the territory yourself. It's in the quiet moments of reading, when a particular metaphor or a simple, elegant phrase lands in a way you didn't expect, that the deepest understanding occurs. This podcast is here to help you decide if this book is worth your precious time. If anything we've talked about today has sparked your curiosity or touched your soul, I encourage you to pick up a copy. Reading it isn't just an act of learning. It's an experience that can genuinely change the way you see the world, and your place within it. You can find a link to the book in the description below. Also, if you found this summary valuable and want to continue exploring the great books on the Billionaire's Bookshelf, please take a moment to hit that like button and subscribe to the channel. It helps us grow and ensures you won't miss our next adventure into another life-changing text. Let's keep growing and wondering together.